This time low side IGBT is working. If I will press overcurrent protection on, now no IGBT will work. This is good working condition of this IGBT control circuit. Assalamu alaikum wa rahmatullahi wa barakatuhu. Friends, welcome back to my channel. In this session, we will perform practical live testing for this IPM intelligent power module. In last video, I discussed how we can verify the power stage using multimeter. If you have not watched that video, I will recommend you can watch that video. Video number is displayed on the screen. Using multimeter, we can verify just only this power stage, IGBT and body diodes. But now we will apply power and we will provide signals, and then we will check the response of that signal on these LEDs. We can also provide 6-line code for high, low, high, low, high, low for 3 phases U, V, W. If you look at this diagram, it is in 3 portions. This portion is a separate portion. And this one, it is separate. These 3 sections are called U, V, W, or phase 1, 2, 3. I will explain testing for one channel, how we can provide input and how we can take output, and we will perform just testing for other 2 channels. I will explain just one channel. Let's start. For output high and low signals, we will use LEDs. One LED, 10 kilo ohm resistor, 10 kilo ohm resistor, second LED, positive 15 volt or 16 volt, and here we will provide input to this display. This U wire, it will reach here to this assignment. If you see, here is positive, anode at positive, cathode 10 kilo ohm resistor, both resistors are connected together. It is connected to anode, and here is cathode. We will provide 16 volt here at positive and negative, and I have 3 sets, 1, 2, 3, 15 or 16 volt. 16 is much better, because if you will use this one, then it will not go to under voltage lockout. I will use 1 kilo ohm resistor, this switch, push button, (10 kilo ohm resistance) and ground. From here we will provide input. This is our input circuit. We will generate test signal, and here I will provide 5 volt, because input side will take only 5 volts. Input signals, OCP1 overcurrent protection, L in 1 low side input number 1, common 1, common power supply for this section, VCC1, it is supply voltage. We will provide 15 or 16 volts, same here. These are VCC voltage, and here we will provide high in, low in and OCP, three signals. We need three signals here for input, positive voltage and ground supply voltage. Then we will connect a capacitor here at these two pins, VB biasing voltage and HS1, that is bootstrap capacitor low side connection here. We will connect 100 microfarad 35 volt capacitor. We will make connection for the first module, that is here. This is output terminal, pin number 32, and we will connect at this common point of the resistors. We will provide this 16 volt positive to pin number 25, that is positive supply voltage. And we will connect all emitters, because this time we are not monitoring the current, so we will connect all emitters to low side. Part number of this IPM is SCM1246MKF. Now I connected U here, then V, this is V, V at this point, and W. I connected U, V, W to this type of output display. This pin number 26, here is pin number 29, and this is pin number 32, the last one. Now here is pin number 1, that is first pin, that is fault out. We will not touch this pin. And then pin number 2, that is OCP1, low in 1 and common 1, pin number 4, common pin number 4. We will apply common voltage. One, two, three, 4. Pin number 4 to the common, and I will connect VCC1, that is pin number 6, to positive voltage. Here are positive voltage. And we need to connect a capacitor here. I am connecting 100 microfarad capacitor low side to pin number 8 and high side to pin number 7. So I connected this capacitor pin number 7 and 8. I will apply positive 5 volt and ground here. This is ground. When I will press this button, we will receive 5 volts. Normally this pin is low. When I will press this button, we will receive voltage. The switch is off, it is low. This common, and we will connect this common here to provide low side rail, and we will provide positive voltage to this converter module. Now we will provide 3 signals. First signal, pin number 2, that is OCP, overcurrent protection. Then high in, that is pin number 5, and low in, that is pin number 3. This is overcurrent protection signal, and this is low in, and this is high in. Low in, when I applied low in signal, low in side IGBT is now turned on. When IGBT will turn on, at that time that LED will turn off. Normally all LEDs are on. This IGBT, low side IGBT, this signal is now provided to IGBT. This low side signal is provided to this IGBT through this logic circuit, and this IGBT is now on. When I will leave this one, immediately after that I will press high in. This IGBT is off now because we have provided bootstrap capacitor. When this capacitor will discharge, it will turn off. I will repeat again. This is low in, low side IGBT is now on. LED is off. It will remain on until this signal is high. But when I will leave this signal will low, the second will high, because in normal circuit it works with high frequency. But now I am testing it manually. So when I will leave this, immediately after this I will press this button. We can see until the bootstrap capacitor will remain charged, LED will turn off. When this capacitor will discharge, it will turn off automatically. This time low side IGBT is working. If I will press overcurrent protection on, now no IGBT will work. This is good working condition of this IGBT control circuit. It is 15.57. It is good. If this voltage will drop less than 15 volt, because we are not providing high voltage at DC range, we are applying 15 volt. When this voltage will drop, its under voltage lockout for high side IGBT will turn off and high side IGBT will not work. Now low side in, low side IGBT is on, high side IGBT on. When the capacitor will discharge, it will turn off. If I will remove this capacitor, now low side IGBT is working, but when I will turn on this button, high side in, this IGBT will not turn on because bootstrap capacitor is missing. Now let's connect it again. On, leave it on. When this is on, overcurrent protection is on, pin number 2 is high. That is due to any reason, any time when current sense circuit will give signal, or microcontroller will give command signal to this pin OCP, overcurrent protection, this section will turn off. Now we will move to the second stage. The same working phenomena. Now I will shift all the pins to next stage. Bootstrap capacitor. Each section has its own power supply, positive and ground voltage. Now positive voltage at pin number 14. These are positive voltage, positive to pin number 14. High in to pin number 13. This is high in. Then common to pin number 12. This is common to pin number 12. Then low in to pin number 11. This is low in. It is input signal. Then OCP, overcurrent protection, to pin number 10. This is FO, fault out. We are not touching to fault out. If there is fault, that time this pin will become high. Now we will monitor these two pins, because this time we are dealing with this section. Low side IGBT. Low side IGBT, high side IGBT. Yes, low side IGBT. If the capacitor is small size, at that time this high side IGBT will turn on for very short time. Low side is on, and it must remain on because its logic circuit will remain on. High side, if overcurrent protection is on, no IGBT will turn on. So this section is also good. Let's check the third stage. OCP1, OCP, overcurrent protection, to pin number 18, 17, this is 18, then 19 low in, 19 low in, 20 is common, 21 high in, this is high signal to drive high side IGBT. Then pin number 22, that is VCC, supply voltage. And capacitor positive terminal will come to pin number 23. Here is pin number 23. And this capacitor will reach here at pin number 24. Now we will check this section. Low side IGBT turned on. High side IGBT turned on. Low, high. Capacitor discharge, it's off. Overcurrent protection if on. No IGBT will turn on. So this IPM is good. So in this way we can verify IPM out of circuit. If you enjoyed this video, hit the like button. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.